Okay, so we're live on YouTube, and we can start right away.
All right. So can you see my screen? Hello? Hello, can you see my screen?
Yes, we can see your screen.
Okay, thank you. Hello everyone. It's nice to meet you online, of course. So before we begin the introduction to Python, we will be using Jupyter Notebook. And to get around that, we don't need to install any special software in our computer as long as you have internet connection, which I believe you do if you can watch me right now. So you just have to go to your browser and type Google Colab and Google Colab. So you search for Google Colab and you click on that. So you search for Google Colab and you click on that. Now, in order to be able to have a view of the notebook we're working with, you have to click on GitHub. So when you do this, we will provide you the link to the notebook from the chat section. From the chat, through the chat section. So I think I have it here. You just have to copy it, then go to GitHub. Oh my collab. Okay, we post this and we search. So we just wait a few seconds. We should be there. Okay, it's still loading. So, all right. Here is it. So before we get started, Python is a high-level programming language which enable us to do a lot of stuff, from general purpose computing to application specific computing, meaning you can use Python for IoT, you can use Python for machine learning or AI. So Renewable Africa 365 has decided to take on this project, which is a 6-week project or 6 webinar series split across different periods of the weeks into the future. So we'll be talking about introduction to Python programming language, attributes and data structure, functions and method definition, and how we can use them, object-oriented programming language or programming in Python. Basically, the way Python is, people we thought is just a functional programming language, meaning you just create some functions here and there and you call them. It has a drawback. So it's not just only in Python, but the beauty part of Python is that it can do functional programming as well as object-oriented programming. And object-oriented programming is based on classes. So you will know more about this in the future. So don't bother yourself about knowing everything in this first class. So we'll also talk about Python libraries we can use for AI, so that as you will be encouraged to carry out projects and taught on different kind of AI applications or branches of AI like natural language processing, machine learning, through supervised learning models, things like that. You will be introduced to some libraries that will gradually step you into those stage for you to be able to learn how you can use Python for AI, and of course help us build a real world solution in solving problems in our society through renewable Africa 365. So we also talk about Python built-in functions as well. That will be in the future. So today we'll be taking on this first one, which is introduction to Python programming language. And under that, we'll be talking about Python as an interpreted language, and variables and data type, Python objects, Python operators, why we need operators. They are very important. And of course, we'll introduce you into expressions and conditional constructs. They are very relevant. They will be needed across whatever project you are doing. So let's go into Python first as an interpreted language. It is a high-level programming language for general purpose programming or computing, meaning it can be used in several applications for Internet of Things, which is IoT, for artificial intelligence, which can be natural language processing or deep learning, lots of it. I don't want to be calling those big words for you because it doesn't really it's not what is to motivate you or drive you. What will drive you is you understanding the very basics of Python. If you can get the concept, I have not always believed the code is the solution. I believe the analytical knowledge is the solution. So first we have to give you a ground knowledge of the coding. So once you have the basic knowledge of Python, then you can get challenges or problems that you'll be able to break down to a basic level, then you apply Python on it. So Python was introduced by Guido van Rossum in 1991, which is around 30 years ago, and it has been developed year in, year out. There are two major versions of Python. We have Python 3 and we have Python 2. However, Python 2 is gradually going out of support or development. Of recent, in this year 2020, after lockdown, Python 3.9 was released. So that's to tell you how active the development is going. And very soon you'll be talking about Python 4.0. So, and as the development is going, features are removed and features are added to the versions of the programming language. Um, you can install Python locally on your computer and use it via Anaconda. Anaconda has lots of package that it comes with. So you can install your Python. You can install different version of Pythons through the Anaconda environment, so that each environment has different version. However, you can also make it easy for yourself using the free Google Colab, which we are currently using, if you don't have a big project to handle. If you have something intense or huge to do with Python and you intend to do it with Google Colab, it is advisable you purchase, you pay for the paid one, because if you do that, you have access to more features. So how do we know the version of Python we are using? From this little code, first I will introduce you to libraries. The beautiful part of Python and what has made it to be so strong and so relevant in the field of computing, artificial intelligence, and the rest is that there are lots of Python module, and those modules, which can also be regarded as libraries, are always under development. Once they are developed, they are uploaded uh, into a repository where you can easily import them and make use of them. In this case, from platform import Python version is just a simple code that helps us print the version of Python we are using. So why we'll have talked about this, and when we say interpreted language, Python likes to, the way it was designed, Python executes code line after line. So it doesn't take the codes together and execute them once. Unlike compilers, compilers do that. Or when you have a programming language on a compiler can handle that. But Python, basically, wherever you keep it, it loves to execute code line by line. That is for the Python programming language. So we'll talk about Python variables and data type. Basically, when we start talking about Python, it looks a bit complicated, but it's a very easy programming language that many people love to practice because it's easy to use. Most of the problems you will be facing have been somehow handled at a basic level. So you just have to import the solution and then apply it to your problem, and you realize you've solved it. So to talk about variables and data type, because they are two interwoven topic that has to be discussed. Given Andrew Ng defined variables are containers as containers for holding data and are defined by a name and value. In this case, X is the name and the value is 5. So the equal sign you are seeing here is actually the assignment operator. We'll talk more about operator later, but we have to take a look at a very simple one here. The equal sign doesn't mean that X is equal to 5. That is different in computer science. You have to see that for you to have equal, it has to be, you have to have double equal sign in this equation. But if it is single equal sign, that is just an assignment telling you that X is holding 5 as a value. So imagine X being a plate that can contain food. So the plate can hold any form of food, all right? So you can use it to hold, you can use it to take rice, you can use it to take beans, you can use it to take bread. So in this case, the plate is holding number. So X is the plate, is the variable holding the value 5. So we now have types of values that can be stored. We have numeric values, which are numbers. We have strings, which are text, what you see here. Any of them can be stored. We'll talk more about them later. And we have identifiers and reserved word. These are very, very important, and I will also give you examples about them as we go on. I won't handle everything here. At the point they come in. But what is meant by reserved word, like the word print that you see right here, you cannot use it again. You can't use it to store variable. You can't use it as a value, neither can you use it as a variable, because it is a special function, rather regarded as a method. It has been dedicated to be used to print output on your computer through Python programming language. So you can't use it to define anything on your own. You can use it somewhere else. Like the way you use this X is because X has not been used in Python programming language to be a particular special word. But in Python, print have been used, so you can't use print again. So we take it further and talk about numeric values. And please, I do hope the link is shared on the chat section. The link to the GitHub repo is shared on the chat section so that whoever doesn't have access can have access to it. So we have for example, we decide to store the value 10 inside this variable iNum. I just define it. I make it out of nothing, so you can call it anything, but just make sure it's not a special keyword. So you can store this value in it, and then you can print it, and you can print the type of the value stored in the variable. The type, that means the data type. Let's run it. So you can see the value is 10, and then the what is stored inside is an integer. So that brings us back to this. Numeric values can be integers, which are numbers like this, or whole number, and then they can be floats, which can be 10 points. Any number with decimal places, those can be regarded as float in Python. Unlike in other programming languages like C++, where you have them define long and short number, things like that. We'll take a look at why Python has decided to take that and be like, okay, can you stay aside? We are moving forward. So Python doesn't do that anymore, unlike in C++ and other languages. Then we can also store complex numbers in Python by defining the number with a letter J. That means it's a complex number. Likewise, you have the long, which is this. Well, Python doesn't support that. Python 2 used to support that, or Python 3 doesn't support that anymore. Why? Because we are moving forward. We have choose to upgrade our level and then take a step into the future. So that brings us to an example of float. We can run this and see for ourselves what happens. Okay, that's the value is 10.5, and the data type is float. So you can see the value here, 10.5, is stored under this fnum variable, and we decide to print the variable, the value stored inside the variable fnum, and also we choose to print the data type of the value stored in the variable, which is float. So we also try that with complex number. Let us be sure. Let it not be as if we are trying to manipulate you, okay? So that when you come into Python, you'll be very sure you are at the right place, all right? So no one is manipulating you, okay? So we store this value, the complex number, inside this variable cnum. And as we did earlier, we print the value stored inside the variable cnum, and we print the data type as well. So you can see this is the value, and of course the data type, which is complex. So you see, it's a very lovely thing. It's an attractive scenario. It's a relationship that is very beneficial. All right. So let's think about what happens if we now decide to see a long int being stored in Python, and then we choose to print it out. What happens? When you do that, it simply throws an error telling you invalid syntax, because we are using what, Python 3. You see, Python 3.6. So we are using Python 3, and Python 3 doesn't support such um, form of storing values. So there's nothing like long int or short int. You just store the value, and Python handles it on the background. You don't have to know anything. So we now run a very simple example of summing arithmetics, or summing using arithmetics rather. Okay, 3 plus 5, and then we print out the value of the addition using the plus operator. And what the plus does, it doesn't add A and B. It actually add the value stored in A and the value stored in B. So you see, Python is very easy for anybody to use. So I encourage you to go into it. I will share with some references with you, and of course, in the future, by the time we finish the 6 webinar series, you will see that Python is actually very easy to learn. So let's talk about string. Having talked about numeric values, we can store characters. These are regarded as string. So we can store them in a variable astr. I just define this. You can name yours whatever you like. So don't feel pushed or confused that, okay, what is this? It's actually something you can do, anybody can do, as long as you have seen someone who gave birth to a child and decide to name the child. All right, that means you can name this. Okay, so don't look at it as a very big stuff like you see a underscore str and you be like, wow, this guy is a professional programmer, he's from the space. No, it's something you can do as well. So take it simple, take it one step at a time, and you become better at it. So let's run this and see what goes on. So it just print the type of this variable string that we store inside this, and it's telling us that it is what? A string. So you can see it's that simple. And then we still have the same here. I have no idea how okay, I know. I thought I repeated myself twice. So this is what actually happened. Here we print the data type, and here we print out the value stored in the variable a underscore str, which is hello world. So that's basically what happened there. And how about we decide to print a character out of this string, because each of these letters are characters, okay? Including the space in between is a character. It's regarded as a character by Python. So we run this and we see what happened. Okay, we've just print out what the first letter of the string, and mind you, we use we start from 0. Do not forget this. We don't start counting from 1, we start counting from 0 in programming or in computing. It's a very basic fundamental thing. It's not like maybe C# does that and C++ doesn't do that. No, it's fundamental and it's common across all programming language. So how about we print this from 0 to 5? From 0 to 5, we now print these letters one after the other, and that's what you get here. So we've talked about numeric types, we've talked about string. So let's take a look at dictionary data type. They are very important, they are very relevant, especially when you are working on advanced stuff. You may not be doing those string and numeric values anymore. You may have even forgotten that they exist. You don't even have the time for that. You will now be dealing with dictionary data type. They are very important. And it's not only dictionary. You have dictionary, you have list, and you have the order, which I hope I've not forgotten. Okay, tuple. Yeah. So we start with dictionary. It consists of key value pairs enclosed in curly brackets and can be invoked or accessed using these square brackets. So how do we do, what do we mean by dictionary data type? We want to store a data in this variable dic, right? So to do that, we have to store the value in such a way that there is a value and there is a key to access the value. So in this case, this is your key, and red is the value stored in the key. Age is a key, and 10 is the value stored in the key. So the key will enable us to access the value. That's the importance. That's the number one importance. Secondly, you can store different data type here. Like what you see, you just saw string and you saw numeric. So you can store multiple data type without being pushed about, okay, how do I handle this? This is supposed to just be numbers. This is supposed to just be string. I have combination of them. How do I go about it? Or the other way around. So dictionary just make it easy for you. Okay. So when we do that, we just run this and we print out everything in the dictionary. So what if we have decided to change our mind? We just want to print one value, which is this red. So what we do is this: we pick the name, then we pick the key. So whatever is stored in the key will be printed out. This is the name, then this is the key in square bracket as we talked about it earlier. So when we click on print, it brings out the value stored in that variable for you. Likewise, we can do more. Yes, in this case, we want to print the values stored in all the key. Okay, all you simply need to do is dot value. Dot value is a method. We call them method, and I will advise you not to be much confused. This dot, we are using it to reference this method called value with double coily, with a coily bracket rather. So basically what we are doing is that we are using this method, otherwise also known as function, to pick out what is stored in this DIC variable, which is read and which is name and age. So by the time we do that, we print it out, it automatically pick their value and print them out for us without stress. So we have a way of bringing out each value stored in the variable, and we have a way of bringing out all the values stored in the variable in a very simple way. So that's how lovely Python is and friendly to everyone, you see. So how about the keys? Are we not going to talk about it? Of course we will. So we also have another method which is called keys. So this method, which I already let you know that is a function defined by someone, that's the lovely part of Python. You can sit down and think of something, you develop it, and push it to PyPy, and anyone can use it. Okay, the same thing we are doing here. We are using someone's effort. So I think we owe that person gratitude who have created this method, and with this method we can access the keys stored, the keys in this variable DIC. All right, so just like how we have this method help us access the value stored in the variable DIC, the same way we can use keys to access the key that stores the variable, that is used to access the values rather. So that is that about dictionary. They are very friendly, they are wonderful, we love them, they love us. All right, so let's talk about list data type, and I hope you are not yet exhausted because we will soon be rounding up. So there's a lot that you need to understand, but we'll put it at the very basic level for you so that you won't find it confusing. Okay, so we have list data type, and a list data type contains items separated by commas and enclosed in a square bracket. In this case, you don't have key, you don't use key. It's very similar to dictionary. It's just that we don't use key to access the data. But then we have means of accessing the data, okay? So we have, you can see numeric numbers are stored, and characters are stored as string as well, and we have floats stored in the same variable. Then we now have a single character stored in it. So it's very beautiful. You can also have it store word. Those words are seen as what? String. So we can access them one after the other. We can print list, and we can print from 0 to, which is this and that, which is from 0 to 2. You know, we agree that the counting starts or initiates from 0. So 0, 1, and 2. So let me run this, and of course you see what happened. The first one is to print everything the list has in it domain, or what it has stored. So we print everything out. Then the second one is to print from 0 to 2, which is starting from here. And this, okay, this was actually ignored in this case. Sorry, that's the difference between the list and dictionary. Yeah. So dictionary will definitely capture from 0, 1, and 2 to the last one, but in list we ignore the last number. So, and having done that, we can also play around with this. I didn't include this earlier. Let me see if I can do that immediately. So we can print list 1 and we just say 0. Okay, let's try this. So you can see we print out hello. That is for this variable list 1 that stores hello and word separately. So if you want to access word, all you need to do is put 1. You don't need a key, unlike dictionary, and you have that. But then dictionary is a little bit more secure. You can hardly make mistake as long as you are referencing the right key. Unlike this, where you may mistakenly do that because there are no keys for you to reference to. So you're just using numbers to pick them. So, and we have one other thing, which we'll talk about the more under strings. I think we've not gotten there. We'll soon get there to talk about strings. So we can, I think during operators, yeah. So this asterisk operator actually helps us to multiply. So when you run this, whatever is stored in list 1 is hello world. Do not forget, we stored hello separately from world, and both are in the same variable, but we didn't make them together. That's what I mean by separately. So when we decide to print it, with the help of this asterisk, it multiplies whatever is in the list by 2, and you have hello world, hello world. And you can also use the addition sign to add the operators together, which is in this case we are adding the values stored in list with the values in list 1. So it's not basically summing them, but rather aggregating the values. Will I say bringing the values together? It's not summing them like, okay, 1 plus 1 is equal to 2. But in this case, it's simply saying, okay, 1 and 2. You have them at both sides. We are bringing them together. And that's why you have this. And of course, hello world is also in this new variable. So you can store this in another list. If you want to play around with it, you can just say, okay, list 2 is equal to the addition of this and that. Simply put like this. You can say list 2 to list plus list 1. So that is how it is, and you can print out the value of this. So you can also convert numerics into string, and what is going to happen when we do that? You have 83, and it looks funny. You'll be like, okay, where on earth do we add 8 and 3 and we got 83? If we can do that, why don't we apply that in our account so that we can make more money? Yeah, I think it's very important. But then this is just string. What string does, it doesn't when you apply the plus sign operator on string, what happens is that it just bring this and that together, not really summing them, but putting them together. It's just like, okay, when a man marries a woman, okay, you don't end up having one human being physically. No, you have a man and a woman, two people standing together. All right, that's what is happening here. You just have 3 and 8 and 3 being brought together. Okay, so let's talk about tuple. Tuple uses parentheses rather, so define its variables, and you can store numbers and strings in it. So unlike list, which is enclosed in square brackets, tuple uses what? Parentheses. And do not forget, dictionary uses curly brackets, so that's the difference between them. In case you see it in someone's code, for you to be able to easily identify which is which, you have to use these special characters, like parentheses, or what you saw above on list, which is the square brackets, or the one way above, which is the curly bracket for dictionary. So let's give it a test and see. Okay, our code actually throws an error, and you now start wondering, why on earth will our code throw an error? So whenever your code throws an error, before we continue, here is what I intend to describe to you. First, you look at the error type. Don't run to the code and start trying to fix it. First, you come to look at the error type, and then you see the explanation of the error, which says can only concatenate tuple, not string. Okay, so, and if you don't understand, Colab has a way to help you search by clicking on this search Stack Overflow. So Colab try to pick this error and search it on Stack Overflow, and immediately you see list of solutions. You have to click on each one to view it and understand what is happening. So that one is the good part of Colab. Okay, then here we have different stuff. Before I talk about the resolution or about what is happening here, let's first run this and see what we had. Okay, this will also give you error again. Tuple object does not support item assignment. Are you seeing that? Now this is simply the two errors you've gotten so far is simply an explanation of tuples are immutable. You can be making changes on what is stored on list or on dictionary, but not tuple. Tuple seems to be very disciplined, will I say, or very self-centered to some extent. But when you want to store variables that you don't want any maybe confusion to manipulate the variable, yeah, like someone like me who can easily put 10 in one variable, and before you know, maybe I have not eaten and I just forgot something, I change the 10 to 20, it becomes a problem, right? So, and I start looking for the bug, not realizing that I actually created the problem in the first place. So you can use tuple. Tuple will not allow you to make unnecessary changes that will cause you problem. Okay, so that is the essence of these two errors we have put here. You cannot just sum tuple up. That's why you got the. You cannot just take one variable or take what you stored on this and store and add it to what you store on that. It becomes a problem. That is one. Two, you have to also understand that you can't change what is stored inside the variable, which is immutable, and then you can't just sum up two different variables together in tuple. It's difficult. Okay, so you can see tuple is holding here 1 2 3 and hello world. It can hold string and number, and you can also print it out. You can print one of the data stored or one of the values stored in tuple out one after the other, your choice. So we'll take a deep dive or a step further into Python objects. What are they? Classes are object constructors and are fundamental component of object-oriented programming in Python. They are composed of a set of functions that define the class and its operation. So when we talk about classes, when we talk about functions or function, they all depend on objects. So, well, one thing we have to understand about object-oriented programming is that it actually makes our work easier for us via the use of features such as encapsulation, inheritance, and others. So we will talk more about it. Remember we agreed that this is introduction to Python, so we are not here to cause you harm. So we are going to take it one step at a time, okay? So that at the end of the day, you get the concept. I am happy you get the concept, and that makes me believe that you will come for the second webinar series, okay? So um, object basically is the instance of a class. You want to define an object, or the first thing you do, you define a class. That class is an object. And it's very, very important in programming language, especially when you are doing something of um, of bigger importance. You are handling a huge project. You can't be running one script at a time from each line. Having from each cells that you have here that you have seen so far, we'll be running this, then you click on that and that. No, 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 no. But with class, we can define a particular characteristics, and then it becomes a template with which we define others. Okay, so it's very easy to understand. And the basic way of doing this is what? An object, then the method name, then the parameter list. The parameter lists are the arguments, are the things you'll be passing back at the end of the day. So do not forget this. Whenever we talk about class, it depends. Basically, there are two things you have to do. You have an object. It consists of two things: an object and a method name. So to do this, I know you may have been somehow lost a bit. So let's take an example. I think example will help us better. Okay. But what we are talking about is very simple. Now we have an input type here. So let me click on this. Okay, the code is asking me to enter a name. So I'm going to enter my name, and I'm going to hit enter. And it said, hello Joseph, how are you? Which is what we entered in this print type. So, but did you realize something happened? This upper, this is a method. Okay, this is a method, but the parameter list is left empty. So the method, this is an example of class. Okay, what it basically does is that we just use this decimal point to identify the method we intend to use, and then we type the name of the method, in this case no parameter list, and then we call it upper. Basically does what? Change small letters to uppercase letters. So that is what class does, and anybody can define a class and anybody can make use of a class. All right, we'll go deeper into it. It's just to introduce you to what classes are all about. So we can now define our own classes by ourselves. In this case, if you remember what we said about classes, we have the object, the method name, and the parameter list. So we just use the one created by someone. How about take a look at the one we created ourselves? So the parameter list is the object you're seeing here, and then the this is the class name, and then this is the object. So what we are saying, we are just initiating a class, and inside the class we can have a definition, which is a function basically. We have some parameters or arguments in the function, and we are saying, okay, we want to store species and we want to store name. So what do we do with this? So even though it seems to be a bit complex, I know how to get around it for you. So when you take a look at this, what we have done here may look very insignificant, but when you take a look at the next example, now we want to make use of the class we have created above. So the first thing we do is that, okay, we are calling on the class, and then we are saying we want to change whatever is stored on the variable species. We are changing whatever is stored there, and the name we are changing it. So we are saying, okay, the species should be dog and the name should be Scooby. So we are changing everything stored inside here. And the beautiful part of Python, we have also talked about, that is an interpreted language, if I go ahead and run this, it throws an error. Do you know why? Because I have not run this. So it runs line by line. Okay, so then I can run this, and of course it went well. So I can print my dog, and I can print my dog.name, and it looks very simple and easy. You see, the dog is Scooby, but when you say my dog, it doesn't print out anything. It only tells you the address where it is stored. But when you now say my dog.name, it tells you the it goes ahead and pick whatever value is stored inside this. We've talked about this at the beginning, so it's quite simple and easy. And then we'll have the fourth, which is Python expression and operators. They are very important. We've been using them since, and I believe you've been taking a look at them. We have the plus operator or addition operator, and the essence in strings, it helps us to concatenate. But when it comes to numeric values, what does it do? It adds them together. So let's take a look at this example where we have 5 plus 6 stored in variable p, and we have get and space and money stored in variable q. So when we print them out, you see 11, that is an addition, and here is a concatenation. Okay, so we can also use the negative operator, and that one is not an operator we can use in strings, so we can't use them. Okay, we can only use them for numeric value rather. Then we have the asterisk or the multiplication sign, and that one we can use them for numeric values as well as strings. So we just click on this and see what happens. You see, for the values, that is 3 multiplied by 4, and you have 12. And for the strings, it multiplies the number of times the strings appear. And we have the division sign, of course, modulus and square, and the floor of a division, which is this guy. So this is not difficult to understand, so that's why I put the examples together. When you do division, 12 divided by 3, you have 4. But when you do the floor of this, things change. It just takes out the reminders, it takes it off and just give you the whole number value. That is what this floor does, this double division sign. Then you have the percentage sign. The percentage sign is for modulus. So when you do modulus, the remainder or what is left when you divide it, 18 divided by 3 gives you 6. So that is remaining 1 because we have 19 here. So that prints out 1. And this double asterisk actually does the square. It gives you the square or raised to the power of whatever it is. So let's just run the code and you see what I'm talking about. Okay, you see, basically that's what it is. So I still have a brief of explanation here. Let's say 25 divided by 4, you have 6. And that should be 24. So you have a remainder of 1. So if it is modulus, then your answer will be 1. But if it is a floor of division, you have your answer to be 6. It ignores or wipe off this remainder. But modulus wipes off this and takes the remainder as the answer. Okay, so we have other operators. You've been seeing us use the operators since. We have the equal sign operator, which you use to compare two or more values. And we have the not equal to, then we have the less than, we have the greater than, and we have the less than or equal to, and we have the greater than or equal to. And now we have examples by the right. So you can compare the values. Is 3 equal to 3? Yes, and this is what is taking us into conditional statement, which is the last part of what we have been discussing. So, so far you've tried to be patient with us, to be able to understand what we are doing, and I hope it encourages you to bring more people to our 8365. Okay, so let's continue. You can have the less than operator to compare this and say, okay, 2 is less than 3, or is 3 greater than 2, 3 is less than or equal to 4. You can use them like this, and we will show some examples so that we won't cause you confusion. Okay, so I thought I have example here. Why am I not seeing them? Okay, we have more. The examples are reserved under the if else condition, so you take a look at that. We'll all take a look at that before we round up. But we also have the logical operators. Do not forget, this is comparison operator, to compare two or more values. Then we have the logical operators. In this, other programming language such as C++ or MATLAB also, they use the double ampersand, and in Python, no, we just use and. That is what makes it very simple and easy for anyone to understand. Like you can say, if 3 is less than 4 and 5 is greater than 4, you see, it makes it very just as if you are talking to somebody. So it makes it easy for anyone to use. And we also have the or operator, which is also under the logical operator, and the not operator. So, and how we can use them. We will use them in more examples as we continue. So this is just to introduce you to Python and its operators, expressions, all about it. So basically, by the time you lay to sleep, you'll be able to say, okay, I think I know Python. Basically, I have idea what Python can do and what Python cannot do. All right. So we talk about the conditional statement. Here we have the if and if else and if else. The essence of all this is that these conditional statements are not possible without the comparison and logical operators. So basically what you have is condition. You have the if, which is a method, and also we regard this as what? Keyword. You can't use if for any other thing. If has been specially reserved for this purpose. So you can't use it for something else. You can't define a variable and say if equal to that. No, no, no. It becomes a problem. Okay. So if is a reserved word, and we have your condition set here. When we say condition, we are talking about something like this and then something like that. Those are conditions. Okay. So then you use the double, you use the colon, then you define your statement, which is the code, what you want to happen. Taking a look at this example, you have num to be equal to 5. We are now saying if num is not equal to 5, what should happen? It will print out a statement. So let's see that. Yeah, you're not seeing anything, right? Of course, the reason why you are not seeing anything is because num is equal to 5. But now, if I change it to 7 and said, try that again. It's not saying, I told you, I told you, I told you, I told you, you won't say anything. Basically, that's what it's saying. So that's the essence of an if statement. You have the if word, which is a reserved word. You have the variable, and you have the value you're comparing it with, and you have your operators sit at the middle of both. The operator is the relationship. Okay, then we now have your statement defined here. It's not just all about printing. Sometimes you can also have some more activities inside this block of code carried out, like arithmetic operations, calling functions, and all of that. You can have a lot done inside there. It's not just to print. Okay, so and you get to know that more because this is just introduction. So we also have another example here. We want to test it and see what happens. Okay, so say enter a number, and I said okay, enter 5. Enter 5. Say okay, 5 is a positive, and 5 squared is 25 by. So I can change this and say 5 is a positive number. Now, let's see if this code actually has understanding. Let's try minus 15 and let's see what happens. You see, that is where it stopped. So that tells you the limitation to the if statement. Okay, it cannot handle further expression, and that gradually takes us to what else. So when if condition is not met, what happens? Let the other condition be met, which is the else. Okay, so that is what brings us here. And we are going to take a look at example because I love examples so much. I don't like talking abstract. Okay, um, so we take a look at this example. In this example, we enter a number, and if the number is less than 0, it prints it's negative. If it is not, it prints it's not negative. So I put 34 and hit enter. Say it's not negative. Okay, so if I run this again and I put minus 6, what happens? It said it's negative. So you see that this is more improved compared to what you have here, which is just an if statement. Okay, so then what if we have lots of conditions? What do we do? Are we going to be writing if else, if else, if else? No. Python also tried to handle that by bringing in a special keyword also called elif. Elif allows you to bring in lots of conditions in between the if and the else statement. It ends with the else and it starts with the if, and at the end, which is the else, we are expected to put your default statement that okay, if it doesn't meet any of these conditions, then definitely it's going to be this last one, nothing else. Okay, so let's take a look at an example because we are almost done. We have a number 5 stored in this variable, which is number, and we said if it is greater than 2, it should print out number is bigger than 2. If it is less than 2, it should print out number is smaller than 2. Else, it should just say number is 2. So we will try this and see what happens. Okay, it's saying number is bigger than 2. At least nobody died. We tried it, right? Nobody died. Everybody is safe. So let's try something else. Let's make it maybe let's negative 5 and let's see what happens. So it's saying number is smaller than 2. It's very basic and well structured. Whenever you write your code, ensure you put that in mind. Writing complicated code is actually very sweet because when you're showing people, oh, everyone will just be hailing you and you'll be like, wow, I'm the genius in town. But when you want to really solve a problem, make it very simple. And I will not judge you by that because I also do some stuff complicated that maybe a friend of mine or two have to say, okay, Joe, I think you need to calm down. Just take a look at it. Make it very simple, okay? And now I'll be like, oh, I think you're right. I don't know. I'm off my brain. I'm off my head. Something I just don't know what's wrong. So I'll make it simple. So making it simple is actually very important in programming because it makes your work easier and easy for others to understand. So let's take a look at this example. You impute a value. This will take an input, and whatever we put on the input, it will be stored in num, and it will now try to compare it using the equal sign. So if it is equal to 1, you enter the 1. If it is equal to 2, you enter 2. If it is greater than 5, you entered a number greater than 5. If it is equal to 7, you entered 7. Else, the default statement, you enter some other number, which is not within what we define inside this code. So let's try that. We are almost there. And you have 6. You entered a number greater than 5. Okay. So because we have a definition for that here. So you can play around this. And we can also try another example. And of course, before we go, okay, there's something I wanted to show you, but I think it's on the last part of this code. So we can also compare using our or operator and our less than and greater than operator. So we have a lots of operators here, right? Okay, so these operators that we have here, we actually compare them. So to see what will happen if I change this value, let's say I said 25. Let's see what happens, and I click on this. The number is between 10 and 20. You see, that's the limitation of if function. It doesn't think beyond what is supposed to work on. So, but for you to be able to handle more exceptions like this, you have to bring in the else condition and other ones. So here we can also play with an example. I think okay, number is within range, that's 20. And if it is 10, what happens? Let's see, it's still going to tell us something. Oh no, it's not saying anything. It's not saying anything because it doesn't know what to say. So if you now decide to include an else and said, okay, print print this out of range. Okay, number is out of range. Okay, let's try it and see. Oh, it's showing an error. Why is it showing an error? Because something happened. It says syntax error, invalid syntax. So you have to understand those basic things. This is what a syntax error, meaning I type something wrongly. Okay, so you just put the colon there, and you handle that, and number is out of range. Okay, so that is the essence of having an else statement. But when you now have multiple conditions, you now have to add the elif at the middle. So the last one is for me to show you that this is also a keyword, none. You are saying that status is not keeping anything for now. You're not storing anything in it. But before we talk about how this, while we are talking about how this code work, let's take a look at something here. There's something wrong with it which you may not notice because we have not talked about it since. Okay, so we'll talk about it now. Let's watch. The error is indentation error expected on an indented block. So this takes me back to a movie, a series called Silicon Valley. If you watch it, a programmer had an issue with his girlfriend. He went to visit his girlfriend, and the girlfriend was like, they were discussing, and they eventually went into a stage where they had to start talking about tab and spacebar, which one is better in your code? And the programmer picked spacebar, and the lady said tab is better. They were arguing about it, but you can actually use any of them. But I prefer spacebar as well, maybe because I'm a male, just like the programmer. And here is what actually happened. This is why we're having error. Whenever you define this, it is not expected that the next statement should be directly under this condition. Okay, so you're expected to move it forward. And if you still think it is confusing, I will move it like this and hit enter. You see, collab automatically creates the space for you so that you don't make the mistake. Okay, let me also do this. You see, but if we still run it, we'll have a problem with our print. Okay, the print is okay, everything is fine right now. So this is our code, and this is just to print the result of the code. So when you click on this, you see it's teenager. Because why is it teenager? Because 15 is between what, 12 and 20, so the person is a teenager. So these are the book I will tell you to read in case you intend to read the books. These are the books I reference for my for this series. And of course, here are some exercises you can do. And of course, you can also search for Andrew Ng on GitHub to look at it, look at some of his code. It's good. It's just that, you know, he's a professional, so to some extent he drift out of the simplicity and takes it further. And if you don't have the general knowledge that we are giving you at our 365, you begin to find it difficult. So um, write a test program to check if a number is odd or even. That's a very simple exercise. We all know what odd number is and even number as well. Write a program that asks the user to enter his or her name. We've already seen how we can receive an input in our code, and then the program should respond with a message that says hello to the user using his or her name. So that's also another simple exercise I expect you to have run through before our next series, before our next webinar. So create a program that reads the length and width of a farmer's field from the user in meter. So the user enters the length, the user enters the width, then your program automatically read in those inputs and of course display it. You can even take it further and also print out the area of the farm of the field. So then we can also do this, which is write a program that determines the name of a shape from its number of sides. So if the person enters 3, it tells you, oh, it's a triangle. If you enter 5, it tells you it's a pentagon, something like that. So read the number of sides from the user, then report the appropriate name as part of the meaningful message. Your program should support shapes with anywhere from 3 up to including 10 sites. So if in this case, just a little hint, you will use a lot of okay, should I tell you or I shouldn't? Okay, let me just tell you. You use a lot of if else statements. So you will need that to do it. So if a number of side outside of this range is entered, then your program should display an appropriate error message. So we have covered everything that these questions could have think of bringing out as a challenge to you. So you should be able to solve them. Thank you very much, and do ensure that you join Renewable Africa 365. We are here to support you. We are here to help you to use your effort to support our society, to grow the community, and to help people. Thank you. I think at this point I'll be handing over.
Thank you very much, Joseph, for your explanation. You said a lot of things um, that are very interesting, and I'm sure there will be a couple of questions to be asked. So please go ahead and ask your questions. You can unmute yourself and ask the questions you have concerning the first screencast. But while you are properly formatting your question, Joseph, can you please introduce yourself? You skipped that part.
Oh, okay. Thank you very much, Ademola. And I remain Joseph Itopa Abubakar, but you can just refer to me as Joseph Itopa to make it easier for you, and of course for me as well, because to pronounce all the long name is quite difficult. I am the lead ML engineer at our 365 and also a machine learning engineer at Omdina. Uh, all we think about is how we can contribute to our community, to our society. So it's the core of the whole thing. Go out there, earn your keep, and give back. Okay, give back to the society, give back to the community, because you don't know the great person you will touch in the future. You don't know the great person you will give life to, that will become someone who will touch the entire world. That is what our 365 is built around, and that is why I'm here, of course. Thank you.
Okay, so the questions, you can ask your questions now.
Okay, how can I see the question, please?
I think the participants can just unmute themselves and talk directly into their microphone.
Okay.
Or contributions. Okay, maybe no questions, contributions. Um, Otherwise, we can just close the first screencast and announce a date subsequently for the coming screencast. And just as a reminder, this is the first of 66 episodes. So there are 5 more episodes, and the information will be made available to you through our social media channels. So we'll wait for 1 minute, and if nobody has anything else to add, then we call it a day. Okay, thank you, Joseph, and thank you, participants, for taking our time to be here. The program has been recorded on YouTube, and the link will also be posted so you can watch again at your leisure. Thank you very much, and have a beautiful weekend.
Thank you.